All right, guys, so let's go ahead and start. All this should be a review, I hope. And if it isn't, let me know. So yesterday it worked awesome, guys. If for some reason you guys think I'm going too fast, just unmute yourself and say, Chavez, can you slow down a little bit? Or if there's a question that you don't understand, just open up the mic and say, Chavez, I have a question, and can you explain this differently? And I will. So yes, I can see the chat, but I just can't see it right now. I have to push buttons to see the chat. So if you do send something through direct through DM chat, I'll be able to see it, but it might take me a little while. All right, let's get into this. So what's a relation? A relation is anything that you say is has some type of pattern or is associated with each other. So what I mean is if I put an ordered pair and I say X and Y together, and that's a relation because I just put that these two are related somehow. Oh, okay. Sorry, I got a message, guys. Yeah, don't worry. I just for those of you wondering if Canvas, if this class was not on Canvas yesterday, I just published it this morning, guys. So now it's live. So don't worry. It should show up today. We'll troubleshoot it in a little bit when we all go to Canvas. All right. So that's a relation. Let's see. So what did I say? Any set of ordered pairs, pretty much. So any set of ordered pairs. And it doesn't really have to be a pair, guys. If you're talking three-dimensional, it could be X, Y, Z. But for now, we'll just say that. And then what's a function? Well, any function, I guess by definition, it passes the vertical line test. So you can just say passes vertical line test. You could also say X's don't repeat. X's don't repeat. Yeah, don't ever repeat an X. Stay away from X's, guys. That's just bad news. But yeah, and there it is, guys. So that's pretty much it. Like passes vertical line test, X's don't repeat. And why is it not a function? Because anytime you have an input, you need to be able to get an exact output, like one output. So if you type in a 3 and you get two different Y values, like that's not cool. Like I want to just get one unique output. So that's why with a function, you can always tell what you're going to get because based off what you input, you get a specific output. So then from there, we have these right here, examples A, B, C, D, and I'm going to go in alphabetical order, guys. So example A. Is example A a function? Well, let's see. We have 2, 4, we got 3, 5, we have 4, 8, negative 1, 7, and then we got 2, 10. No, it is not a function because X's repeat. So we can't have that. All right, letter B. Is letter B a function? There's one coming out of that X. There's one arrow, 1, 1. Yep. I see that I have one unique output for every X value. And so yes, this is a function. All right, let's go to the next one, letter C. You can already see that I have X's repeatings again, negative 3, 2, negative 3, 5. So this is not a function. If you were to plot those points, negative 3, 2 points, negative 3, 5 points, notice that if I draw a vertical line, it would cross through those 2 points. And then letter D, it passes vertical line test. Yes. So there it is, guys. A, B, C, D, pretty straightforward, nothing extreme. And then I have this question, what does it mean to be one-to-one? So one-to-one, by definition, just means every unique X has a unique Y. Every unique Y has a unique X. So vice versa. So what does that mean? Not only do X's not repeat, Y's don't repeat. So what does it mean in layman's terms if you're still like saying, Chavez, I have no idea what you're saying. Can you just tell me in plain English? Okay, I'll tell you in plain English. It means that it passes vertical line test and passes horizontal line test. So if you look at letter D is not one-to-one because it does not pass the horizontal line test. Not one-to-one. See, and there it is, guys. That's all it means. Cool or not cool? I'm assuming you guys said cool, but I can't tell. So, all right. So real quick, guys, you're gonna notice it says determine of the relation from set A to set B. So they're telling you there's a relation there. Is a function. If it is, so it says determine if it's a function. If it is, determine whether it is one-to-one and whether it is onto. So this onto, all it means is that all y's are taken. All y's are taken. That's all it means. So, looking at this, are all y's taken? Yes. So it's definitely onto. Let's see if it's a function. Do we have one coming out of each one? Yes. Is it going to one specific? It is. So this is not only a function, but it is also one-to-one. And there it is. I think someone has their mic on. If you could just make sure to mute your mic so we don't have too much background noise. Or maybe it's already muted. Sorry, guys. All right, example 2b. Determine the relation from set A to set B is a function. If it is, determine whether it is one-to-one. Oh, so it's the same type of question. A, B, C, D, E. There's one coming out of all of them. Perfect. All the Y's are taken. And boom, boom, boom. Oh, check it out. 4 has 2 arrows coming into it. A goes to 4 and C goes to 4. So it is a function. It is onto, but it is not one-to-one. So a function, but not one-to-one, or onto. Where are you? An onto function, but not one-to-one. There it is. Did we understand that, guys? It can't be one-to-one because you can't have 2 different x values approach the same y value. It would be this situation. It would be this situation right here. See, 2 different x values have the same y value. All right, example 2c. Determine if the relation from set A, okay, it's the same question over and over again. So let's see, A, B, C, it's definitely one-to-one. It has, because it's going to one unique y, but I noticed that there's a y by itself. So this is not onto. But it is a function, it's one-to-one. A one-to-one function, but not onto. Because for it to be onto, guys, I need to be taking all the y values. Cool? Cool. See, just like this guy. All right, let's keep going. And then finally, the example 3, determine whether the following graph represents a function. I have debates over this. I've spoken to professors on this, and I think this is like a high school issue, really. If you're talking by the strict definition of a vertical line test, then no, not a function. But I can pick letters in terms of x and y. I can make a conic section. This is just a conic, guys. But oh well. You know, hopefully you studied hyperbolas and all that other stuff in algebra too. Well, probably not, right? Because we had a corona. Darn it, corona. Oh well. All right, guys. I guess I don't want to cheat you guys of an education. These graphs here are similar. But this one is a function, while this one is not. And so you can start making a debate like, well, what if you, translate this 90 degrees, or what if you just, I mean, there's a relation that you can obviously make both graphs on Desmos, but for now, we'll leave that for another topic, guys. All right, function notation. Function notation is f of x. Why did they choose the letter f? Probably because the word function starts with an f. So yeah, and then you can use any letters. It doesn't have to be f. It could be g of x. It could be z of x. It doesn't matter, guys. It doesn't even have to be an x. It could be like f of happy face, and you can say, oh, okay, this is a function based off of happy face. And if I want to use this one, I could say 2 times happy face squared minus 3 times happy face. And I know this last happy face came kind of dumb, but let me make him look a little smilier. Well, okay, I think the second edition was even worse there. But you guys know what I mean. It doesn't have to be a happy face. It could be, if you don't like happy faces, you can do triangles. F of triangle equals 2 times triangle squared minus 3 times triangle. And whatever you insert for triangle, you just plug in wherever you see a triangle. So that's all it means. So if I come over here, this, if you just says f of 3 equals 5, really that's just a coordinate. When x is 3, the y value is 5, if you're talking about a graph. So yeah, and it's or just a point, a coordinate, or whatever. So if I come to example 2, they're telling me what f of x is. F of x is 2x squared minus 3x. They want to know what f of 4 is. I'm just going to plug in, guys. 2 times 4 squared minus 3 times 4. And that's it. And we could leave it like that, guys, but we're pretty smart. We can do this. So let's see, 2, and then 4 squared is 16. And then 3 times 4 is 12. And then I just double the 16, which that's 32. And I subtract 12. So let's see, 32 minus 10 is 22. Subtract another 2. Oh, that must be 20. And then we'll do a little happy face. Yeah, that looks all right. Sorry, guys. Maybe if it's too early for you guys probably don't want to see happy faces. Like, it's too early for me. I don't want to see happy faces. Like, all right, so I'll stop drawing happy faces. All right, letter B. So it says here f of x plus f of 2. All right, I'm going to go ahead and circle the f of x, guys. This is f of x right there. So whatever I have in blue, it's going to be in blue, I guess, 2x squared minus 3x. And I'm going to go back to my red color, the neutral. And then I'm going to write plus. That's that plus right here. And then in parentheses, I'm going to write what f of 2 is. Let's see, 2 times 2 squared minus 3 times 2. So let's see, equals. Now I'm just going to write everything in red, guys. So here we go, 2x squared minus 3x plus, you can just drop the parentheses. I guess like the same joke that we used last time, drop it like it's hot. Okay, sorry guys, maybe it's too early for you guys. 2 squared is 4, 4 times 2 is 8, so 8. And then 3 times 2 is 6, so minus 6. So what do we have? 2x squared minus 3x. 8 minus 6 is 2, so you just put plus 2. And there it is. We're done. All right. I'll give you guys a little bit just so you guys can write that down while I take a sip of my coffee here. Oh man, that's good coffee. All right. F of 2x. So I'm going to write 2 parentheses 2x, close it, squared, minus 3 times 2x. And then I just keep expanding it, guys. 2 parentheses 2x times 2x is just 4x squared. Close it, minus 3 times 2x is just 6x. And then I just double the 4x squared, so that's going to be an 8x squared minus 6x. And there it is. That's it, guys. Give you guys a little bit of time. F of h plus 2. Wherever you have an x, I'm going to insert h plus 2. 2 parentheses h plus 2, close it, put a square on it, minus 3 parentheses h plus 2. Now I'm just going to expand it. 2 parentheses. So hopefully by now we're fast at how to FOIL really quick. H times h is h squared plus h times 2 is 2h, but you're going to have 2 of those. So it's going to be plus 4h plus 2 times 2 is 4. Close it, minus, and then 3h minus 6. And then just distribute this little dude here. So, hey, little dude, let's distribute you. So 2h squared plus 8h plus 8 minus 3h minus 6. We combine like terms. I see an 8h, I see a minus 3h, I see an 8, and I see a minus 6. So let's see what we have. 2h squared. Let's see, 8 minus 3, that's 5h, so plus 5h. And then 8 minus 6, that's 2, so plus 2. There we go. We'll do the guy because it's too early for you guys for a smiley face. All right, what happened here? This looks like my ex just went voodoo or something. All right, f of negative x. So f of negative x, short-term memory, I gotta look up at the equation there. 2 parentheses negative x, close it, put a square on that little guy, minus 3 parentheses negative x, close it. And then we're just gonna expand it, guys. 2, and then negative x times negative x, that's just x squared. And then negative times a negative, that's a positive. And there it is, you're done. Maybe that was the easiest one so far. On letter F, it helps if you put a little bracket around the f of x so you know that that negative is outside. So negative on the outside, bracket, and then I'm just going to write my equation inside, 2x squared minus 3x. Excuse me. Oh, that kind of scared me there. All right, Distribute the negative there, guys. So we have negative 2x squared plus 3x. And there you go, guys. We got another one down. Yeah, by now it's getting cumbersome because they're all the same, guys. All right, so now we have x plus h, so we got two variables. This is really the same as like letter D, h plus 2, but that one had a variable and a number. So I'm going to write, let's see, what's my equation again? So 2x squared. So I'm going to write 2, wherever there's an x, I'm going to write x plus h. X plus h. Close it, put a square on it, and then minus 3 parentheses x plus h. All right, let's expand it, guys. I'll put the equal sign over here. There's that same 2. I'm going to expand it. I'm going to FOIL the x plus h times x plus h. X times x squared, plus x times h, that's xh, but there's going to be another one, so that's 2. There's 2 xh's. 2xh. Delta math probably puts 2hx. It doesn't matter, guys. I just like to have the x with the number personally, but probably the correct way is to have the h before the x because in the alphabet, the h comes before the x. But I just like to have the x next to the number because I've already been used to that. Plus, h times h is h squared. So just put h squared. Close that little dude. Minus, distribute the 3. So 3x minus, don't forget the negative there, minus 3h. Okay, so now we're ready. Distribute the 2. So you're going to have 2x squared plus 4xh plus 2h squared. And then you still have that minus 3x, minus 3h. Let's see, does anything combine? I do not see anything that combines, guys. So there it is, leave it alone. We got it. Okay, last one here, letter H. So it says 3 times f of x. We're gonna do the same concept that we did for letter F. So I'm gonna write 3. And I'm gonna put in bracket what f of x was. F of x was 2x squared minus 3x. 2x squared minus 3x, close it. And then from there, I'm just going to distribute the 3. So that's 6x squared minus 9x. And we're done, guys. Well, we're done with that page. Oh, hold on, someone's reaching me. Okay. All right, guys. Let's go to this guy. Oh, well, I guess before we continue, do we feel okay? Do you want to unmute your mic and say, yes, I feel okay? Or just say yes, I guess.
Yes.
All right.
Yes.
Awesome, guys. Awesome. All right, let's keep going. So you're going to see this here, and it's going to look scary. This is called the difference of quotients. Relax. Quotient just means like something over something, and then the difference just means subtract. Don't be scared of this. It's just a formula. You've actually seen this since junior high. This really just means slope. It really just means this. Y2 minus Y1 over, and the H just means change in X, X2 minus X1. That's really all it means. So it's just slope. We are not going to interpret any problem at the moment, because we're rookies. But later on we will. You're going to be using this throughout calculus all the time, and probably maybe in physics, algebra-based physics. But if you get to calculus-based physics, then you're going to be using this all the time. It's called a derivative, an instantaneous rate of change. But you know, we're not advanced there. We're not there yet. We're rookies, so we're getting there to advanced math. All right. So right now, all we care about is using this. That's all we care about right now. So it says find the difference quotient. So it wants this equation, and they tell us what f of x is. So we already have f of x. We got this part. We need f of x plus h. So notice that we have f of x plus h. It's the same equation, by the way. Look, 2x squared minus 3x. We've been using that forever now. Well, since I had 2x squared minus 3x, here is f of x plus h right there. I'm sorry, guys. Let me mute my phone here. There we go. So there it is. So there's my f of x plus h. So I'm going to write it. Oh, what happened here? Okay. I'm going to write it right here. F of x plus h, what that is. Let me see what that is again. Can I see it? it is 2x squared plus 4xh plus 2h squared minus 3x minus 3h. All right, so here we go. I'm gonna rewrite this equation. Whenever I see f of x plus h, I'm gonna write it in blue. So bullet, and I'm gonna write f of x plus h. Oh, you know what? Maybe I should erase the bullet because some of you guys might think that's multiplying. This is just a new line, guys. F of x plus h minus f of x all over h. I just redid the equation equals, I'm gonna write what f of x plus h is. That's first. So I'm gonna write 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus, and now I'm doing the f of x part. And why did I put a parenthesis? Because I have more than one term. 2x squared minus 3x, there's my f of x. All this is over, what is it over? H. We're okay so far, guys? You can unmute and say, yeah, I get that, or just say yes.
Yes.
Okay.
Yes.
Yeah.
Awesome. Excellent. All right, so now that we did that, I'm gonna go ahead and distribute this. And now that I know what's in blue there, I'm just gonna write everything in red now. So let's see, 2x squared plus, you know what? It's still f of x plus h. I'm gonna write it in blue. You don't have to if you don't want to, guys, it's okay. 2x squared plus 4xh plus 2h squared minus 3x minus 3h, and then go back to my neutral, minus 2x squared plus, because I'm distributing the negative, 3x all over h. All I did was distribute the negative. So catch up. Catch up. We used to have a teacher. She was so funny. She would always go, I hope you have your fries. And then the kids would look at her and be like, what are you talking about? And then she would go, because today's ketchup day. Like, do you guys get it? Because, you know, you dip your fries in ketchup. Okay. Anyways, oh man, Ms. Ranjan, she was hilarious. All right. Continuing here, I'm going to zero out the numerator, guys. So whatever zeroes out is what I'm going to cancel out. So I have a positive 2x squared and I have a minus 2x squared. So those cancel out. See? I have a negative 3x and I have a positive 3x. So those, I shouldn't say cancel out, I should say zero out. Those zero out. So now what do I have left? So now what I have left is, let's see, 4xh plus 2h squared minus 3h over h. So write that down. Now I notice that in the numerator, there's an h in every term. So I can factor out an h. And if you factor out an h, you're going to have 4x plus 2h minus 3. All this over h. Now on this one, I can say cancel out instead of zero out because I have an h on the top and an h on the bottom. So because I have an h over h, that's the same thing as a 1. So that cancels out. And now what you have left with is just 4x plus 2h minus 3. And there it is. That's my expression. That's your difference of quotients expression. Cool, right? I think it's pretty cool, guys. All right, we'll give you guys a little bit of time to write that down if you didn't get a chance. Don't worry, all this will be uploaded on video as well. I'll probably upload it tonight around 6 or 7 p.m. All right, example 4. So if you want to just, I will give you time, guys. So if you just want to listen, just listen and don't worry. I will give you time to write stuff down. And worst case scenario, I'll upload the video and you can write everything down. But I'll give you like a minute to write everything down. So just listen. So I already have f of x. This is my function. So I have this guy. What I need is an f of x plus h. So let me write this in blue. I'm going to write f of x plus h here in blue. F of x plus h is equivalent to 1 over, wherever there's an x, I'm going to write x plus h plus 7. There's nothing in front of that parenthesis, in front of that x there, or in front of the parentheses, so I can just drop the parentheses. I'm not going to say the joke. I'm just going to say drop the parentheses. So there it is, 1 over x plus h plus 7. So that's my f of x plus h. So now I'm going to write this equation again from scratch. So I'm going to write f of x plus h, and then I'll go to my red, my neutral color, minus f of x, all this over h. This is what I'm doing. I'm just writing the difference of quotients equation. So what is f of x plus h? It's going to be 1 over x plus h plus 7 minus, and then f of x is 1 over x plus 7, and all this is over h. So now I have like fraction within a fraction, so maybe fractionception or something. So now what I want to do is, in the numerator of my big fraction here, I want to go ahead and subtract those two. So the way you do that is by getting a common denominator. So how do you get a common denominator? Well, it's simple, guys. On the one on the right here, the one in red, I'm going to multiply this dude by x plus h plus 7 over x plus h plus 7. And the one here in blue, I'm going to multiply that by x plus 7 over x plus 7. Now remember, we're not robots. The reason why this works is because x plus h plus 7 over x plus h plus 7, that's equivalent to 1. This guy's equivalent to 1. And anytime you multiply anything by 1, you get itself. Same thing with the one in blue here. I'm going to multiply it by x plus 7 over x plus 7. And anytime you do that, you're multiplying it by 1 by itself. Excuse me. So I haven't changed anything. So here's what happens. X plus 7 times 1 is just x plus 7. So now I'm just writing everything in red, guys. X plus 7 over. And then on the bottom, I could distribute the x plus 7 times x plus h plus 7, but I would get a very long polynomial. It would be ugly. So I'm just going to leave it like this. X plus 7, x plus h plus 7, minus, and then 1 times x plus h plus 7 is going to be x plus h plus 7 over x plus 7, x plus h plus 7. And all this is still over h. All right. I think we're okay so far. Don't worry. I'm going to give you guys some time to write all this stuff down. So now, I'm going to go ahead and group the numerator there because I have the same denominator. From the big fraction, I'm just going to look at the top. So I'm going to write x plus 7, and I'm going to distribute that negative there, like that, see? Minus x minus h minus 7 over x plus 7, x plus h plus 7, and I guess technically all this is still over h. Now tell me if I confuse you guys here. I'm going to rewrite my numerator the way it is. I know a lot of stuff zeroes out, but I'm going to rewrite it. X plus 7 minus x minus h minus 7 over x plus 7, x plus h plus 7. And then tell me if you guys freak out if I write the h there. Say, Chavez, I'm freaking out. Or Chavez, no, I don't get it. Or just say, Chavez, I'm confused.
I don't get it.
Okay, thank you, miss. You are courageous. Trust me, there's several people that don't get it. I promise you. Well, I shouldn't use the word promise because I want to go to heaven. But yeah, I'm sure there's several people. Several people have not gotten it in the last 2 days. So let me tell you why it works. So I'm gonna do something called a side note. So I'm gonna write side note, and please, guys, stop me. Please stop me if we don't understand something, because my purpose is to make sure that you get it. Never be scared to ask me a question. We do not judge here, guys. We never judge. All right, side note. If you have a fraction like AB and I have another fraction like C over D, and I told you to divide those, you would go, okay, I'm going to divide those. So I'm going to go A over B divided by C over D. Do you guys agree that that is the same thing as saying A over B times D over C? You can say yes or no. Do you guys agree with that?
Yes.
Perfect. So this is AD over BC. We're happy with that. No one's gonna say no to that. All right, so let's pretend that D equals 1. So now, you know what, I'm gonna need a bigger space. Let's pretend, so now let's say I have A over B, and I wanna divide that by C over 1. Well, that's the same thing as saying A over B divided by C over 1. So it's kind of like saying this H is like over 1 there. So now that is the same thing as saying A over B times 1 over C. I want you to notice where the C is at now, A over BC. So I'm going to erase the 1 down here, and let me change the color so it's easy to see. So that C here is like the H. And look what just happened. Look at my end result. The B and the C are together. So I can just move that C and put it right next to that B there. Do you guys see what I did there?
Yes.
Perfect. So this is the same thing. So let me erase this H there. And I'm gonna put the H still back, but that's like saying H divided by 1 right here. So I can just move that H right there, and there it is. Just like the C. Does that make sense to you guys?
Yes.
Okay,
Yes.
perfect.
Yes.
Awesome, guys. See, this is what I want to make sure that we are giving you guys the best education possible. So please do not ever hesitate, because we want to make sure that you are entered into a top university, the university of your dreams, and you score super awesome in the SAT and ACT math. All right, so here we go. Now that we've conquered that situation there, now we're ready to zero stuff out. So on the top, I have a positive 7 and a negative 7. Those zero out. And then I have a positive X and a negative X. Those zero out. The only thing you have left is an H. You have a negative H, actually. So I'm going to erase this H over 1 here so I can have some space. So I have a negative H over, and then I have X plus 7, X plus H plus 7, and then H. So now what cancels out, now you can say the word cancel. Now what cancels out is the H's. Now you still have a negative 1 here. The H's cancel out, you have a negative. So my answer is negative 1 over X plus 7, parenthesis, X plus H plus 7. Now I did have a professor, so hopefully he's not watching my YouTube videos, but if he is, no big deal. I did have a professor who wouldn't, I don't want to say he took off points. He did, by the way, but he would just warn me all the time. He wanted the negative all the time in the front of my expression. And then he would go 1 over whatever. X plus 7, X plus H plus 7. Man, all of that is not going to fit. But he wanted the negative always in the front. Guys, it does not matter. I did do it his way only because he would make me. But it does not matter if this negative is in the top there, or if you move that negative to the very front. Both ways are correct. If you